Hello everyone, and this talk is about our work on discerning technical patterns for professional soccer teams and enhanced topic model with applications. And this work is done while I was doing my internship as Big Data Lab of Battery Research, and it's joint work with Hengshu, Wei Hu, Zhiyong, Shen from Big Data Lab Battery Research, and Yuan from School of Mathematical Science, Peking University. And as the topic indicates, we are interested in the problem of finding technical patterns automatically from soccer match logs. And the core idea is to use some unsupervised probabilistic model to do a clustering of similar passing patterns. And in today's talk, I will firstly briefly talk about the background of our research, and this is the state of sports analytics in the big data era, and also the problem we are interested in and the core idea of our solution, followed by an overview of our approach. And then in the second part, I will introduce the main model we use in our approach and how the data are pre-prepared and how this preprocessed data are used in our model, and also some novelty of our model over existed model like FDA. And in the third part, I will introduce some of the applications that we have developed and experimented with real-world data. And this includes technical pattern discovery and also path segments annotation and the spatial analysis of player roles. And then in the end, I will discuss briefly about the strengths and weakness of our approach and a few directions for future work. Okay, so we are now in an area of big data, and with the rapid development of wearable devices and sensor technology, and also the technology of tracking the players and balls in a match and in videos, and the mobility information of players and balls can be recorded in an extensive form of match logs. And so with this rich and fine-grained data, it's a natural question that if we could develop some automatic system to process this fine-grained data in an online manner or an offline manner. And the approach we developed, the automatically approach, has several advantages over traditional approach. That is, we use some automatically programs for analyzing large amount of data, so we can get the results in a more swift, even more quickly, and also the result can be more stable, and the whole approach is more scalable to the large domain of sports analytics. And we can also see in the right plot, we have demonstrated the data we have used for our experiments. And we have plotted the passes of a particular player of man unit. And every pass is represented by a black line, and the start point is a blue dot, and the yellow dot represents the end point. And this is the kind of data we have in our model. And the problem is whether we could use this kind of data to find technical patterns automatically. So our problem is that if we could find a soccer team's technical patterns automatically from this passing data, and as so previously, we have this low-level raw data. So we have, and our interest is the high-level techniques. So we need to build the connections from the low-level data to a higher level top of techniques. So to tackle this problem, we use some hierarchical modeling method to build the connections from the passive to the tactics. And another difficulty is that the data cannot be generally modeled by a simple model, since soccer match is indeed a game between two teams of players, and it's the real dynamic of playing is involves cooperations between within teams and also arousal behaviors between teams. So we have to use more. Also, we have only the trackings of the balls and the players' movement without the balls are missing in our data. So we have to tackle this problem, we use heterogeneous data to have more information into our model to try to infer the technical patterns more accurately and to lower the noise of the inferred technical patterns. And a whole overview of our approach is in 3 stages. First, we'll do segmentations, and this is to segment passing data into small chunks of passes, continuous passes. And in the second stage, we will fit our team tactic topic model and the pass segments. And in the third stage, we will use learn tactical patterns for our applications. So in the first part, we will introduce how we prepare the data and how we segment this passing data into segments. So this is an example of the data we have, and for this we have this is the synthetic data, and we have Aaron and Bob and Kelsey in the red team, and Joy, Kevin, and Lucas in the blue team. And in this log, we have recorded every ball touching Yuan during the match, and this including passes and turnovers and ball out and possible other ball touching events. And for passes, we have recorded the position of the pass, that is the start point and the end point. And then we will recognize a particular type of events as two types of events. One is a stoppage and one is a turnover. A stoppage means the game is paused. This is usually due to a blowout event, a foul or a goal, and so on. And the other kind of event is turnover, which means the position of the ball is changed from one team to another team without pausing the game. And we recognize these two kinds of events in the data and mark them as a boundary of the segments. So that's how we segment the passing data into several segments. And we will use this kind of data for our further analysis. So this is synthetic data, so it only consists of two passing segments. In real data, there's average about 5 passes in a segment. And this is the second stage of our approach, that is to fit our team tactic topic model on the segmentation of passings. And so first we will define what is a technical pattern. A technical pattern contains two parts of information. One is a player interaction network, and another is player position. By player interaction, we mean the passing relationship between players, and it's modeled by a directed graph on players times players. It's a directed graph since the pass is directed. And also we have player positions modeled in the pattern. That is, for each player and each technical pattern, we have assumed a Gaussian distribution for the player to distribute on the playing field. And a key idea here is that a player may play different roles in different tactics. So we focus on on players instead of roles, and which can enable some analysis that will be seen in the following slides. And this is about how to connect the raw technical patterns, raw parsing segments to the technical patterns. And this is modeled as a generative process. And we first, it can be think of, we first draw some technical patterns from prior distributions. And this K is a preset number. And we, for each technical patterns, there are two parts. We can first draw the player interaction part and then the position parts. And in the second step, we will draw theta. This is for each segment. That's how the technical patterns are distributed in each segment. And finally, we will draw each latent technical patterns for each pass. And this is done by first draw the latent assignment and then the player interaction part, that is W, and the position part, that is X. So as a comparison, we will first introduce how our model is related to the classical LDA. And if we think of W as each pass, that is the player interaction part, we can use LDA to do analysis. And our model can incorporate more information by use position of each pass in the model. So with this position information visible to the model, we can see that the learned technical patterns have more compact spatial patterns. And the inference of a model is based on collapsed GIF sampling, and that is to say, for each segment, and in each segment, the passes, the latent assignment of technical patterns for each pass is sampled into convergence. And now we have learned the technical patterns of passing segments, and in the following, I will introduce some applications that we have experimented with real-world data. First, we can do a visualization of technical patterns we have learned from the data. And recall that we have two kinds of information in a technical pattern. There is a player network and also a spatial distribution of the both. So incorporating both part of the information, we can see this is a technical pattern. A defensive technical patterns involves a goalkeeper and two or three defenders, and some midfielders. And this, when we recognize technical patterns like this in the data, we can know that this is defensive. The team is in a defensive style of playing and maybe looking for opportunities, so just killing time, so like this. And since we have latent assignment for each pass and each segments, we can color these segments according to the dominating technical patterns of this segment. So this is a visualization of a match between Barcelona and Real Madrid in La Liga, and the match finished in 4-3 in favor of Barcelona. And this is a first half, and we can see each team scored 2 goals during this first half. And the first score of Barcelona is by Iniesta, with Messi's assist in the attacking region. And we can see that this is successfully recognized by our model as an attacking pattern in the left side. And the second score of Barcelona is by Messi, with Alba and Iniesta's assist in the left side. So this is also successfully recognized by our model as another attacking pattern in the left side. And for Real Madrid, both the first and second score scored by Benzema, with Di Maria's cross from the left. And we can see that the technical patterns assigned for the pass segments leading to the goal are the same. That is pattern 2, and it's also an attacking pattern in the left. So in this way, we hope to give a clear demonstration of the match, and this visualization we hope can help to can help soccer fans and also coaches and the club managers to improve their analytics or watching experience of matches. And here is a path segment annotation result for 24 matches of Barcelona in La Liga. Each row represents a match, and the match arranged according to the natural order of match days, and different colors represent different technical patterns as well. And we can indeed see the evolution of the technical patterns. And an interesting result is that the variety of tactics is related to somehow related to the strength of the opponent. And we can see that there is we can see that for one confronting with a stronger team like Real Madrid and Atletico de Madrid, the technical patterns is of more variety. And for one confronting with weaker teams, and the technical patterns are in one color or in two. So this may suggest that the style is more constantly without many changes. So a more detailed analysis of this can be found in our paper. And we also can show that it's possible to do a spatial analysis of players to different roles. And this is a decomposition of players' active regions by different technical patterns. And this is the decomposition of player Pedro Rodriguez of Barcelona. And most of the times he plays in the left side of the playing field, and sometimes he plays in the right side of the field. This is because that he is considered as a good substitute for Lionel Messi. So this may be when he's doing the role of Messi. So he plays in the middle or middle right side of the field. And this is with our model, we can, since we have a separate position distribution for the players in different technical patterns, so we can do the active region decomposition of a player. This is an advantage over the analysis on player roles. So as a summary, we have developed an approach to analyze technical patterns in soccer matches. And the main idea is to learn the locations and passing interactions of players simultaneously, which makes our learned technical patterns more spatial compact. And the empirical results show that the technical patterns are localized, and it can be also used for several novel applications. And a few future works, including using fine-grained data. Since we only have trackings of both, so if we could have continuous position of players, we can model the match in great details. And also, we can explore the effect of game state to the actual style or technical patterns of the team playing. And also, we would like to explore whether there's a pattern in the transition probability on technical patterns, or is there a temporal information that can help we find a higher level of pattern. And we are also interested in developing more applications of our models. Okay, that's it. Thank you for your time.
Questions? So, in one of the last slides, you alluded at, looking at replacing Pedro and Messi.
Yeah.
Have you thought of even trying to model how would a team of, these models of players would work together?
Yeah, it's an interesting problem.
Sure.
Yeah, the problem is that we have only trajectory of both. So we are missing out the information that how players running without the ball.
Yeah,
So it's a little
bias.
difficult. Yeah.
All right. No other questions? Let's thank our speaker once
Thank
again.
you.